Well, hello, lovely people. How are you doing? Welcome back to the final part of this video where we've actually only got one more question to do in this walkthrough paper. It's been a great journey. And speaking of which, this last question is indeed about a journey. Let's get on to it. So below is the velocity time graph of a car journey. Work out the average acceleration over the first 20 seconds of the journey, and we want to state the units of this acceleration. Okay, so we've gone from, so average acceleration just means what is the change in velocity over the first 20 seconds. So we start at 0 and we end up at 20. So just going to draw a line like that. And at 20, it seems like it just about gets to, what is this? 14.4, 14.8, 15.2, 15.6. So it's going up in 0.4s. Okay, so that looks like about 14.8. So the change is, it goes from 14.8, obviously take away 0. That's the change in velocity divided by the change in time. 20, take away 0. So essentially 14.8 over 20. Okay, can we simplify that a little bit? I guess we can. So dividing both top and bottom by 10, quite unorthodox, but that's what we're going to do. We get 1.48, and that's over 2. Then dividing that by 2, we get 0.74. And the units, well, it's meters per second at the top divided by seconds, which is mathematically meters per second squared. So 0.74 meters per second squared. Just out of interest, or for anyone who's thinking about it, another way you can write that is 0.74 s to the minus 2, just using laws of indices. Means the same thing. Use the graph to calculate an estimate for the deceleration of the car when t equals 35. So this is different. So they're not asking us for an average acceleration, but rather an instantaneous acceleration. So at 35, I'm going to draw this one in blue. At 35, we're going to draw a tangent. So you get a mark just for drawing a tangent. I'm actually going to use the ruler tool just to make sure that we get this correct, because this is what you'd have to be doing. Got to be quite pernickety with how you draw this. So the tangent's going to have the same gradient. That's the idea. Because working out the gradient of a curve is a bit trickier than working out the gradient of a straight line, because it's always changing. But if we draw a tangent, we kind of capture it at that one particular place. So now we're just going to work out the gradient of our tangent. So we can see that there's one point here which has coordinates, what is that, 35, 10? Yeah, 35, 10. And we've got another nice point here, which has coordinates 48, I guess, 40,8. So we're going to work out the gradient of that. So that's going to be the change in velocity. So this time it goes from 10 to 8, I guess. So 8 take away 10 over the change in time. So that's 40 take away 35. So it's just a gradient thing, isn't it? So that's minus 2 over 5. So minus 2/5 or minus 0.4. And again, the units for this deceleration is going to be meters per second squared. So we can say minus 0.4 for the acceleration, but the minus just means that the acceleration is going in the opposite direction, or in this case, slowing down. So we don't actually need to put this minus. We can just put 0.4 because they've asked us for the deceleration already. And then again, the units are going to be meters per second squared. Again, you can of course write it as 0.4 ms to the minus 2. And that is it, guys. You've made it all the way to the end of this paper. So again, just make sure that you review the whole paper using the walkthrough. and ensure that you can answer every single question. If there are questions that you don't know how to do, then of course you can find some resources. You can use Corbett Maths. You can use shout out to also Maths Genie. Yep, that's another really good one. To find some extra questions to practice. And of course, you can use my YouTube channel to find questions on particular topics that you are struggling with. Take care for now. Goodbye.